So I want to talk a little bit about the LC3 instruction set.
Sure.
Which I think is, a very powerful instruction set, and that you can do so much with it. But it's very simple, easy to understand. So can you talk about how your kind of dual role of educator and architect came together to create the LC3?
Yeah. So I suspect that I would not. So the LC3 didn't happen just like that. I mean, I thought about what do I want to put in this instruction set. And I have the benefit of being an architect now for what, 50 years? And so I've seen a lot of computers. And so every computer, the instruction set is a little bit different. Some of them are very different. And so I could draw on what they do to say what's important to put in here. And my, in fact, I'm flattered that you think that the instruction set is simple and yet rich, because that was exactly what I wanted. I've seen some computers where the instruction set is rich, but it's a nightmare for the student to try to master it. There's just too much he has to memorize. I didn't want that. I wanted an instruction set that would fit. In fact, you've got the book. If you look at the inside cover, you'll see the formats of all the instructions. It's sufficiently simple that the kid can grab it all in his brain with very little effort. Right? And I wanted that. At the same time, I didn't want to have just a Mickey Mouse, a simple instruction set in the sense that you couldn't do anything with it. So I very carefully put in instructions that mattered, and so even though there's less than 16 opcodes, it's a rich set. So it's a rich set, but yet the number is small, which allows the student to grok. You understand the Vonnegut's word grok. Grok the instruction set. And no, it didn't come out overnight. I worked on it. In fact, the instruction set from the LC, so the LC3 is because the LC1, LC by the way is little computer.
Right.
And when I was at Berkeley and taught the architecture course, I needed a little computer to have them implement. That was the LC1. Impossible to program. It just had one register, an accumulator, Ugh. So when I taught the course the first time, I introduced the LC2. Well, I got it wrong again, see, because I did things badly, and so now I think I got it. The LC2.
Three's a charm.
I think 3 is a charm, actually, because then the next edition will not change the instruction set.
Now you picked 16 bits, right? You could have picked, there are 8-bit machines, right? There's a lot of 32-bit machines, right?
Most
a lot
of them
smartphones
are 30. No, most
32-bit.
of the instruction set.
But you picked. Well, that's the size of an integer. But you also picked an instruction size that was 16 bits.
So I would say so. Most of the, I think this is true, that most of the fixed length instructions are 32 bits.
That's right.
Now there's the x86, which is variable length, as you know.
Right.
But most of the fixed length instructions are 32-bit instructions.
Yep.
There's a danger if you have 32 bits, you're going to want to use them. 8 bits is too Mickey Mouse. There's nothing you can do with an 8-bit instruction, although there have been some designs for pedagogical reasons that use 8-bit instructions. What I wanted was something was big enough that it could be useful, that you could actually sink your teeth into it, but not be so big that it was going to... I am big on doing such that the student can get it without memorizing, or with a minimum amount of memorizing, and 16 bits just felt right to me, and it restricted me to a 4-bit opcode, which means only a maximum of 2 to the 4th or 16 opcodes. I've seen, in fact, there's a popular textbook in computer architecture that uses a pedagogical machine, and the author of the textbook did not write the textbook for that pedagogical machine. Another guy did. And it goes on, and the kid can't master it. It's just there's too much there. With a 16-bit instruction, you can sort of work it in your head. You can look at 16 bits. 32 bits is just too many. So I felt that 16 was and I'm delighted with the, that I got it right. The 16 bits is right.